Hello everyone. In this video, we will see the performance parameters of medium transmission line using nominal pi method. For this circuit, consider an equivalent per phase circuit of medium transmission line. Here, we are considering the capacitance of the medium transmission line at sending end as well as receiving end. For this, consider sending end voltage Vs, sending end current Is, load L. At receiving end, the voltage across it is Vr. The current through capacitance which is considered at sending end is Ics, and the current through capacitance which is connected or considered at receiving end is Icr, receiving end current Ir, and consider the lumped capacitor at sending end and receiving end as shown in figure. The value of these capacitances are considered in the form of shunt admittance. It is given as Y by 2 and Y by 2 at both the capacitance. The transmission line parameters are resistance and reactance, which forms the total impedance of transmission line. For this part, consider current IL which is passing through the transmission line. Now, let us draw the phasor diagram. For the phasor diagram, we are considering the reference voltage as a VR at angle 0. As we know, the load is inductive in nature, hence we can draw the phasor IR lagging to voltage VR. Now, if we consider the capacitance at receiving end, the current ICR is flowing through capacitance and the voltage across that capacitance is nearly equal to VR. Hence, it is considered as ICR which is perpendicular to VR. Similarly, here also we can draw ICR from figure. If we apply KCL at node at receiving end, it is clear that IL is equal to IR plus ICR. Hence, IL is the equivalent of phasor IR and ICR. We can draw IL here. Now, if we see the diagram, the voltage drop takes place due to resistance and reactance when IL current flows through it. To draw this voltage drop, we have to draw the parallel line as a voltage drop to IL as IL into R. The voltage drop across reactance is perpendicular to the voltage drop across the resistance as IL into XL. The equivalent of this is IL into Z. Now, consider the resultant as the end point connected as forms a vector Vs as a sending end voltage. Now, if we consider the capacitance considered at sending end, then the sending end current can be drawn as perpendicular line to Vs because we are considering the voltage across the sending end side capacitance as Vs. Hence, it will be leading to 90 degree to Vs. Hence, ICS can be drawn like this. Now, if we see the circuit and apply the KCL at sending end side node, then Is can be written as Is is equal to IL plus ICS. Hence, Is is the equivalent of IL phasor and ICS phasor. Similarly, ICS can be drawn here. The angle between Vs and Is as phi s and angle between VR and IR can be denoted as phi r. Let us derive the expressions for voltages and currents. So let us start as usual from magnitude of VR as VR is equal to magnitude of VR at angle 0 as we have taken VR as a reference. Equation number 3. Similarly, IR is equal to IR at angle minus phi r as it is lagging in nature to VR. Equation number 4. Now, consider first capacitance at receiving end as we have started to draw the diagram for every derivation from receiving end side to sending end side. Similarly, we are deriving the expressions from receiving end to sending end. After this, we will determine the current through capacitances. First, we will calculate ICR is equal to, according to Ohm's law, it is I is equal to V by R. Hence, ICR is equal to VR upon minus j xc is equal to VR upon minus j. Xc is nothing but 1 upon omega c. But here c is half of its total capacitance. So c by 2. It becomes equal to VR upon minus j into 1 upon 2 pi f into c by 2. 2 gets cancelled. Hence it becomes VR, this j, pi f into c. Equation number 5. Now, similarly we can calculate ICS as voltage across it is Vs upon minus j into Xc. Here it becomes Vs upon minus j 1 upon omega c by 2. It becomes Vs upon minus j omega is 1 upon 2 pi f into c by 2. This get cancelled. So it becomes j Vs pi f c. Equation number 6. From equation 5 and 6 we can calculate the current through the capacitances at sending end and receiving end side. Now if we see the figure, we can write Is is equal to ICS plus IL if we apply the KCL at this node. So from this we can determine the current Is as it is written in equation number 2, Is is equal to IL plus ICS. From equation 2, equation 1 and equation 6, we get the value of Is. Now Vs can be written as, from the phasor diagram, Vs can be written as, it is the vector sum of Vr plus IL into Z. Hence Vs can be written as Vr plus IL into Z is R plus JXL. Equation number 7. Now from the values of VRIR, VSIS, we can calculate the percentage voltage regulation and percentage efficiency. Percentage voltage regulation is equal to Vs minus Vr upon Vr into 100. Equation number 8. And percentage transmission efficiency is given by output power upon input power into 100. Hence, it can be written as, for 3-phase 3VRIR cos phi r upon 3VSIS cos phi s into 100. Hence, from these different equations, we can determine the performance parameter of medium transmission line. Here, we can determine the values of sending end current, sending end voltage, percentage regulation and percent efficiency. Thank you.